Thank you all for coming. How many security sessions we have during the conference? Few. I think maybe 2, 3 security oriented. There was a question on one of the keynotes. How about the security of the solution that you were showing us? And somebody said, yeah, it's very important. So I do believe it's important. So I just wanted to give like my overview and awareness session about the container security. It's based on something that I've experienced myself when I talked to various customers and they were telling me what they are doing, etc. So before we start, a little bit about myself. I used to work in telco business for 10 years, mainly doing data services. I work in Huawei Byte Mobile, which was a startup company acquired by Citrix. And last year and a half, I'm doing a pre-sales work in Oracle. And my 3 main products are Linux, VirtualBox, and OVM, Oracle Virtualization. Yeah? Because this is Oracle presentation, I need to present you the safe harbor statement, which means that whatever I'm saying here, the Oracle guys can say, this is not going to happen, and this guy was lying. So this is the standard US procedure in the US corporate. So this session is about 3 things. So yeah, the agenda for this session is I would like to focus on 3 things. One is the host operating system. Obviously, I'm the Linux guy, so the security of host operating systems is important for me. And we obviously tend to forget about this because we are doing everything in the cloud now, right? So who cares about the operating system? The second thing I want to talk about is the image. So the container images that we are using, where they are coming from, and what we are using. And the last thing is the isolation between workloads. And I think this is really interesting, and what is actually happening in the cloud native space to get to the stage where we actually can isolate one container from another one. So let's start with the host. I'm saying that the containers are only as secure as the underlying operating system. And we see that half of the Kubernetes workloads that are in production are actually happening on-premise. Yeah? So most of you probably work with the cloud providers, and you have your workloads in private clouds, and then you don't care about these things. But there's a lot of companies that would like to build Kubernetes on-prem. So they need to do it the traditional way, right? They need some operating system, some application on top of it that spans the Kubernetes cluster, right? So how secure your software is in general? So here's a scenario. You are installing your Linux operating system. You install your software and application that you are deploying. You are testing it, and you are verifying that everything works okay. And you put it in the production. That's the scenario that we all know. And guess what? Well, there's a patch waiting for you, right? So I'm saying that the minute you deploy something in production, there is probably a patch available for it already, right? And you need to somehow get to the state where you need to patch your application in your system, right? So pretty much we can say that we are all running currently unpatched system. Yeah. How many of you are running the latest and greatest versions of your operating system, for example, or the latest and greatest Kubernetes version that's supposed to be the safest, right? Because it contains all the CVEs, right? Not many of you, I guess, right? So how companies like Oracle are doing that in the public cloud? So we have our own public cloud, not the biggest one, obviously. But we need to patch this Linux operating system underneath, right? How do we do it? We use something that is called live patching. And live patching is something that exists for years. It's something that is now included in the Linux kernel since 4.1 version. It's something that SUSE has, Oracle has, Red Hat has, but every solution differs from one from another. So I believe Oracle has the best solution for that. So the idea here is, let's patch the systems anytime we want without disturbing our application, without stopping anything, without moving the workloads from one server to another. Let's just forget about all this. If we need to have a cloud native and everything needs to scale up automatically, everything needs to be autonomous, let's have autonomous patching happening automatically sometime, and we don't need to care about it, right? So how does it work? We can actually, instead of patching the system and applying something to disks, we can actually apply our patches into RAM, into the memory, yeah? And we can change the memory of our operating system whenever we want. So the technology we have, and this is called K-Splice, it enables us to modify various pointers to functions that are loaded in the memory. And by taking advantage of that, we can do something like this. So imagine that you have this is the kernel memory, some visual implementation of your kernel memory. And you have a code of your application that is loaded into this memory, right? This is like a, I don't know, a class, Java class, for example, right? And you identify that you have a bug in one function or one method in your code, right? And this can be a very simple bug that you know how to fix it. So normally, you will need to reinstall the application or update the application and load it again, right? So that in order to refresh the changes. What we are doing is we are just trying to alter the part of the memory that contains the bug. So we are loading a new patched version of the function into a new place in the memory, somewhere aside. So we have a new patched version of the function, we have the old version of the function, and we are just changing the pointers in memory. So while you're executing the code in your memory, and before you execute the function that has a bug, just jump to the different point in the memory, execute the new function, and once you do that, just go back and execute whatever is next. Yeah? So this is a very simple. Idea. Yeah, it looks simple from the picture, but it's actually quite difficult to get to the bottom of it and implement it, right? And these jumps that are on the pictures that are in the picture, these are called trampoline jumps in memory for those who knows how the memory handlers work. So what can we do? We can do kernel patching. We can do userland patching. We can with this method we can patch glibc or OpenSSL. We can also roll back everything without reboot and without any disturbance. We have alerting, so once we applied our patches, we can see if anyone wants to take advantage of the security hole that we just patched. And we have what we are calling autonomous updates, right? So since we have this patching method that doesn't require a reboot, let's just do it whenever we want. Yeah, let's not wait for the maintenance window. So let me show you how this works in action. So this is my Linux system at home. I will quickly show you how it works. So I'm checking my Oracle Linux version 7.6. I'm checking the kernel version. I'm checking the service that is running. This is called Uptrack service, the service that allows me to load patches in an automatic and rebootless way. I have a cron job that is installed automatically that is checking the remote server if there are any new patches for my system. Right? So I have I'm pinging the source of the patches once in a while to check if there are any new updates. All the patches are being downloaded to a temporary directory in var cache, and you can see that these patches are getting to the specific directory, and you will see a lot of tar.gzip files with some IDs assigned to them. Okay, so this is actually what happens behind the scenes. You don't really need to take care of that, but I'm just showing you what's the logic. Let's check the status of my current system. So I will do one command. It tells me that I have no updates installed, and my kernel version is 4.14.35. This is exactly the same version as before. Do I want to install all these patches? And this is like 200 patches, right, that I'm going to install. And you can see that the tool is giving me a nice overview of what CV I'm going to install, what the patch is doing. For every patch, you can see the changelog, what has been changed. So it's very verbose. And if I do the upgrade command, I will automatically update those patches. Go ahead, yes. And you can see that this is like around 200 of patching, and the installation of them is pretty quick, right? And what we are doing at the moment is actually we are not installing those patches on disk. We are just loading new stuff to the memory and altering the pointers, right? And then you get and then you can check that the effective kernel version of the system is now has been changed, right? So I'm checking the uname -a again, because this is the Linux command that tells me the kernel version, but I can still see the old kernel version. Why is that? Because on the disks, I still have my old kernel version. But actually, because I've loaded all those patches into RAM, my effective kernel version is now higher. Yeah? This is a good workaround for those application providers that are telling you need to stay on the specific Red Hat, CentOS, whatever, 7.1 because we only support this release. This is bullshit, right? If somebody tells you that, they don't know Linux. Yeah, so tell them to call me. We can remove patches out in a non-service effective way as well. And what the tool is doing, the tool is also checking if there are no dependencies on the patches, right? So it will check in this example. It looks like this patch has 2 dependencies, so that we will need to remove these patches as well. Yeah. And this is how Oracle Public Cloud is being patched. So it takes us 24 hours to patch the entire public cloud that we have. Yeah, this is happening automatically. Yeah. So if you are considering on-premise deployments, if you want to minimize the overhead of your admin work, have a look at live patching. We are doing it, SUSE is doing it, Ubuntu is doing it. Different ways of doing it, but I think we have the most comprehensive solution. Yeah. So this is one thing. So host operating system needs to be patched. Yeah. You like it or not, it needs to be up to date. Yeah. Don't believe any vendor who is telling you that you need to stay on a specific 7.1, 7.2, 7.3 version. Right. There's no Red Hat 7.3. There's Red Hat 7, there's Oracle Linux 7. 7.3 is just a point in time when there was a lot of patches. Yeah. So let's go back to the slides. The next thing I wanted to talk about is the image. So remember, like people used to say, don't drive with strangers, but that was before Uber, right? Now you're ordering Uber and you're just getting to a random car with random people from random countries. Most of them are like autonomous drivers, they don't talk. So don't drive with strangers. It's very easy to get things from outside world. Yeah. If you want to start playing with containers, you just download container, right? So the question, if I will just send you a bash script, would you just download it and execute it? Probably not, but if there's a container, come on, it's just a container, right? It's isolated. So for example, if you want to download Prometheus, you need to execute this command. So okay, so Prometheus is what I understand the last bit of the command. What is prom? Is this like an official Prometheus organization? I mean, how do we know that? I mean, am I downloading that from a trusted source or from some? Is Docker Hub can be trusted? I don't think so. Yeah, everybody can put stuff on Docker Hub, right? I can upload images to Docker Hub. You can download it. Does it make me trusted provider? I don't think so. Yeah. My favorite one, yeah. kubectl. You've seen it a couple of times here, right? This is very simple. This is new stuff. Just download this YAM file, or you just point to the YAM file, just kubectl -f, and the magic happens, right? Nobody checks the YAM file, right? I mean, sometimes the YAML is like 10,000 lines. I don't know. Do you understand everything, what is happening in the YAML files? Probably not everything, right? It's easy to hide stuff when you have 10,000 lines in your file, yeah? So we somehow got to the point of time that we started trusting those magical black boxes, right? The containers, right? Because this is the revolution. Everyone is putting stuff in containers. You just download it, run it. Nobody looks what's inside. Yeah, magical black boxes. And there is another thing. Let me teach you something. Who knows this guy? Kevin Mitnick, yeah, the famous hacker. So let me tell you a story. In 1992, Kevin Mitnick wanted to obtain, not steal, obtain a source code of Motorola mobile phone. Yeah. So he wanted to change the source code in a way that telco companies wouldn't be able to track him. Yeah, because we all know that telco companies are tracking us. Yeah? So what he did, he just opened a phone book. It was 1992. He called the Motorola office and he asked for a product management of the Motorola phone. Yeah, and he was being transferred from one person to another. Right? Obviously, he used his fake name. At some point, he was suddenly talking to the VP of the product management. Yeah. It's a first success. Yeah, he got connected to a big guy, and the VP asked him, "Hey, are you one of those Arlington Heights guys?" And he said, "Yes, obviously. Arlington Heights is a town in Illinois where Motorola used to have R&D center, right?" So the VP told him, "Yeah, talk to Pam because she's from my team and she will be able to give you the source code for your tests." But Pam was on holiday and she left a voicemail message saying, "Hey, sorry, I'm on holiday. I will be back in 2 weeks, but if you have anything, just contact Alicia." So Kevin called Alicia, right? And Alicia was saying, yeah, I do have an access to the source code, but Kevin, there's a problem. And she told him that the source code is just a lot of files and a lot of directories. So how can I send it to you? Because it's not one file, it's just a couple of files and the subdirectories and another subdirectories. I don't know what to do. So Kevin said, well, let me teach you something. Do you know how tar and gzip works? And she said, no. Okay, so let me be your instructor. So just do these commands and this will create an archive that you can send me. And she did that. And she said, oh, that's fantastic. I learned something new. but how do I send it to you? This is like 10 megs now, and it's 1992. So he said, okay, can I teach you one more thing? Let me teach you how FTP works. Yeah? So basically, what he did, he became her instructor, right? And the easiest way to hack into your Kubernetes clusters, etc., is to become an instructor. So I can put some stuff on GitHub, and I can promote it. Hey, this is my Kubernetes course. Just use my YAML files, have a look at the containers I prepared to you. You can find me on Udemy. I'm legit. Yeah? Yeah? I'm everywhere, yeah? I'm on LinkedIn. I'm working in a fake company. I have this GitHub account, which is, there's a lot of movement of my GitHub account. There's a lot of commits, right? So I mean, people don't need to break to your systems, right? It will be you who will probably be able to install their stuff on your computer, right? So be aware that there is a lot of Kubernetes and Docker and this kind of tutorials available for free, but watch out what you are downloading. Yeah? So getting and building those images, what are the best practices? Trust no one. Yeah. I mean, don't trust containers or images from a random site. Download images from trusted sources. What is trusted sources? I mean, Oracle Container Services Container Registry is a trusted source. It comes with an Oracle big enterprise logo on it. Red Hat, yeah, this is a trusted source. Docker Hub, not really. Docker Store, maybe. Yeah. It needs to be a reputable place, come from a reputable place. It needs to be checksummed, yeah, so you know if anything changed. Be careful with the tutorials. You try to use the slim version of the images, right? The less things you have in the image, the safer you are. Everything extra is an extra attack surface, right? If you need to have bash in your container, think twice, yeah, because usually you don't need to have it. There is a project, Oracle project called Smith. It's an open source project. Smith is a tool that takes your container and removes everything that your application does need, right? Just strips everything off. So in the end, you should have a container where it's just your application and the library, and that's it. But what's the problem with that? Well, if you want to debug something like that, you don't have any libraries, right? So we created another open source project, which is called CrashCart, and CrashCart can automatically load libraries to your containers, and that way you have some debugging tools, right? You need to scan your images, and there are tools for that, like for example, Claire. You have to sign your images, so you need to have a procedure in your company that what I'm using in production has been validated, signed, scanned, etc. Right? And you need to decide on your patching strategy, right? Because it's easy to take a container and use it, but I mean, are we going to use the same container for a year? I don't think so, right? So the security holes will happen all the time, and we need to have a strategy to patch it and redeploy it whenever we want. Yeah. So, okay, so we covered the image. Let's talk about isolation. Yeah, you need to make it happen. So, who thinks the containers are isolated in a way, right? And the isolation is confusing because somebody said in the morning that actually the word container comes from 1983 when Sun Microsystems actually implemented the first containers, right? But that was in Solaris, and that later became a Solaris zones, and they used container zones terminology. But that was totally different to what we have at the moment, right? And some people tend to think that containers these days are like containers in the old days. No, they are not. So isolation, we've seen that picture a lot of times probably. So this is traditional application. in a VM, right? So in a VM, the isolation is nice. We have a hypervisor that isolates one VM from another. But the full OS, it's not really something that we need for every application. So containers were a great solution to that problem, right? We have a Docker daemon, and then we run a couple of containers, and the containers are running natively, and they are sharing the underlying kernel. Yeah. And a couple of quotes from Docker documentation. Docker is a platform for developers and sysadmins to develop, deploy, and run applications with containers. Yeah, I think we can agree. Docker security philosophy is secure by default. I will question that. And to question that, let's take a look at the. This is a scenario that I'm seeing all the time. Somebody installed operating system. Somebody installed Docker. Somebody create a regular account for a developer called Larry, for example. Larry was added to a Docker group, and because Larry wants to run containers, and yeah, we're starting the Docker service, and let's see what the developer Larry can do. Yeah, so let's go step by step. So let's pretend that this is my server container lab. I'm adding Larry to the list of users, regular stuff. I'm adding him to the Docker group. I'm assigning him a password. I think the password was I hate AWS or something like that. And now I can log in as Larry to my host operating system. I won't be root anymore, obviously. So let's just double check my ID. Yeah, looks all right. I'm not root. I'm Larry. I'm in the Docker group. I can now start any container. By default, I'm connected. I'm downloading containers from Docker Hub. So let me download Oracle Linux container and run it. Oh, that's interesting. I'm root in a container, but it's okay. Yeah? We are creating a separate environment. It's isolated, right? I'm root just inside the container. So let's see what I can do. I can create a file in a container, and the file is here. This is good. The owner is root. Obviously, I'm root, so this is fine. If I exit the container and if I go back to the container, what happens with my file? It disappears, right? I mean, that's the whole idea. The file is not there. The containers are ephemeral. Yeah, this is expected. Okay, so what I can also do is, Larry is a smart guy, right? So he started reading about Docker and he found this privilege mode. And privilege mode gives you some more access to the resources of your host operating system. Yeah? And by default, you can run any container in a privilege mode if you spell it correctly. So now what you can see in the container is that you can list the devices that you have on the system, right? So we can see, for example, the disks that I have on my operating system, which I'm using to launch the container. So what do you do when you can do fdisk -l and you have access to disks? What do you do? Well, you mount them, right? You can delete them, of course, but that would be root. So I've just mounted a disk from my underlying operating system. Yeah, I shouldn't have access to it because I'm not root. I'm not root on the system. I'm just Larry, and I can create a file here. And if I exit the container, the file will be still there because I've just created the file on a physical disk that I shouldn't have access to, in theory, right? Because I'm not root. So that's interesting. So I've just created a file on a /boot, and look at that. The file is owned by root. Which root is that? The root from container or the root from the underlying operating system? It's root, right? Okay. So that's interesting, yeah, that you can create, you are not root, but you can create files as root. Okay, so Larry is a developer, right? So he knows some stuff. He can also run a different container. He knows how to run code. So let's do it again. Let's mount this. Let's mount this device, this hard drive again. Let's go to the location and let's create another file, but this time this will be a file in C with a little bit of code in it, right? And the file will be called getroot.c. And if you browse the internet, you can find a lot of examples about something called set user ID, set suite. Who knows what suite is in Linux environment, right? It allows you to run application in a privileged mode. Yeah, so this is how ping works, for example, right? You can run ping like as a regular user, but actually ping needs some special privileges to actually send packets outside, right? You don't have those privileges. Yeah? So what I'm doing is I'm setting a user ID 0, which is root, and I'm calling a shell, which is supposed to be there. It's usually on every Linux system, right? Okay, I've compiled the file and I've created a version that is still owned by root. I can, in the container, what's interesting, I can change the attributes of this file. Yeah, so I'm root in the container. In the container, I can do whatever I want. Yeah. Okay, I can execute the file. The file is there. So now there is a time to get out to my main operating system when I'm just the regular user. And if I execute the file now, I need to type faster. If I execute the file now, it will launch me a shell, yeah, because this is what I coded. But the shell tells me that now I'm root user, right? So I've become a root user on my host operating system by not doing any hacking or automagical work, whatever. This is just using standard Linux knowledge and how the things are done in Linux environment, right? So there's no I can of course browse through etc shadow and I can change the password, right? But the best way is just to keep a file like that somewhere, and whenever you want, you can become root. And in enterprises, once you are root on one box, you can jump through all the other boxes because everyone loves passwordless SSH. Yeah. So once you are root here, you can jump through the entire infrastructure. Yeah. So the isolation in containers, as you can see, pretty much doesn't exist, right? You need to make it happen by default. By default, it's not there. Yeah. So if you are thinking about building your own Kubernetes cluster, which you will be using in production, you need to know SE Linux. Everyone knows SE Linux, right? This is the main thing you disable once you install the operating system. Yeah? Every how-to tells you that, okay, you first install SE Linux, it breaks stuff. Yeah. Unfortunately, you need to know SE Linux. You need to know what seccomp is, how to whitelist syscalls from your containers. You need to be familiar with namespaces, and I'm not talking about Kubernetes namespace. That's a different story. Namespace of Linux kernels. So what your Linux processes can see. You need to know what the C groups are, what your processes can use. And there's a good starting point. Actually, the Docker security guide that was released long time ago, but after they say that this is secure by default, contains a very good security explanations of Dockers and containers. Docker Security Bench is a small project that allows you to scan your container and tell you what mistakes you've done and what you need to change to make the environment more secure. And don't just let running containers as root users, because as you can see, if you are root in a container, you are effectively root on the underlying operating system. Restrict resources, remove set user ID flags on the underlying operating system, right? So that's the point. If you are creating your own container from like a regular Ubuntu or Oracle Linux image, in the container you don't need things like ping, cats, this regular tools or awk that we are using. Yeah? You just need to remove all the stuff if you want to create your own containers. Yeah? And defaults that are used early stays forever. Yeah? This is the main rule. So funny story, Tesla, the famous company, their Kubernetes cluster went down at some point just because the Kubernetes dashboard was available to public. Somebody forgot about it because they just took their test cluster and put it in the production, and somebody found the IP, logged in, and shut down the whole Kubernetes farm. Yeah, it wasn't hacking; it was like a publicly available website. Yeah. Okay, so this brings us to a project called Kata Containers. So can we have a speed and the agility of container and at the same time have the security of VMs, right? So this is the picture with classic container. We have container A, container B, Linux kernel. So what's the idea? Yeah, and watch out. So let's put containers in VMs. Simple as that. Yeah. But wait a second. I think we just moved from that concept. Yeah. So the whole idea was to move out from VMs. Okay, but what the guys did, they created a lightweight virtual machines that can spin up in fraction of seconds, or actually seconds. You don't see the whole overhead in terms of managing the virtual machine. You have the full isolation between workloads, and these are really virtual machines. So it works exactly like it used to work before. It's just faster, right? And this is also interesting because you can have a different kernel on your underlying operating system and in the container. So quick demo. So here's another example. This is my home lab. This is my kernel version. I'm running a standard container first, just like before. And obviously, in this container, if I want to check the kernel version, it will report me exactly the same version as I have on the underlying operating system. Right? This should be obvious, right? Yeah, you can see that 4.14, 35, everything the same, right? Now the only thing, if I want to run a Kata container, the only thing I need to change is the runtime. Yeah? So let me specify a runtime. So now you can see that the kernel version changed, right? Because what I did, I just launched a virtual machine in my environment, right? And I've connected to it. I've launched the container in the virtual machine, and I've just connected to it and run the uname -a command, right? So the question is, what's the downside of all that? Yeah. Oh, and by the way, there's a runtime configuration file which gives you a full control what kind of hypervisor you are using, what kind of image. You can obviously play with that. We as Oracle, we are just releasing a tech preview of this. So we are preparing the images and kernels that we think are okay to use with that technology. So one of the disadvantages, obviously, that maybe you noticed that already, that running a Kata container takes a bit more time. Yeah, because obviously we need to start the VM, etc. So this is my home lab, which is like a regular PC with Linux. So running the first container took me half a second. Running Kata container 5 seconds, right? I mean, it's a significant increase, but please bear in mind that this is really poor environment, right? The other thing would be, resources, right? We need to think about resources. We are now not running only containers; we are running virtual machines and containers. So we need to be careful with RAM and memory consumption. So, just few more slides. So the guys who are responsible for that project, they did couple of tests, and here are the results, right? So if you run a BusyBox with run C, it will just consume 600 of kilobytes. If you run it with Kata, it will consume 100 of megabytes. That's interesting. If you run MySQL, for example, it will consume 160. But it will consume less with Kata for some reason, right? Elasticsearch, 0.3 gigs difference. So it depends. Yeah, you need to test it. I mean, this is still a technology preview. The project is there. We are investing in it. Intel is investing in it. Some other companies are investing in it. But there are still problems to be solved. But what is nice about Kata containers is that this integrates really well with Kubernetes, right? So we don't need to change our whole Kubernetes cluster. We are still using the same cluster. We don't need to change anything. We just need to add another runtime, yeah? And this runtime is written, Kata runtime is written in a way that it should support many hypervisors. So for example, we as Oracle, we are using QEMU, which is a standard kernel hypervisor. The AWS guys, they are working on Firecracker, which is a really light, nice hypervisor. And Kata works with both of them. Yeah? So you're just changing the runtime, the cluster stays the same. The current status of the project is that the first release was in May last year, so it's pretty fresh. The current release is 1.8. What's interesting is that this project is awarded by OpenStack Foundation, not the Cloud Native Computing Foundation. Although we as Oracle, we released the tech preview, we obviously say that this is still experimental because we need to fight problems like how secure is the kernel memory sharing, how good is the performance at scale, what are the compatibility issues, etc., right? And we need more testing and integration with Kubernetes, obviously. If you would like to play with Kata containers, you can quickly build your home lab. Remember that this is nested virtualization now. No? What you will probably do is you are running a virtual machine, and this virtual machine spins a Kata container, which is another virtual machine, right? So you need to have a nested virtualization support. If you want to play with Kata and Oracle Linux, what you need to install is Oracle Linux minimum 7.5 release. We have a scripts to build the Kubernetes cluster, or you can just simply install Docker coming from the Docker engine coming from Oracle. So you can install Docker, you can install Kubernetes. You need to get to the Oracle container registry, download our images for Kata containers and Kata runtime. Kata runtime is Kata runtime. You need to install our QEMU, and you need to install Cryo. So these are all components that are needed to test Kata. You can do it totally for free because Oracle Linux is free. So you can just go to yum oracle.com, download Linux, and install all the stuff. There are steps in the documentation how to do it, and this is pretty much it. Okay, so this is everything from my side.